the limit of a scalar valued function at a point if exist is unique. Okay. Yeah. So did you read the statement? The limit of a scalar valued function at a point if exist is unique. First of all, let us define a scalar valued function and now try to prove. We have already proved uniqueness for so many things, so you must have an idea how to do that, correct? Suppose this is a scalar valued function and let us say let e belongs to s and we say that you want to prove the limit is unique. How will you start? Is there any idea do you have? You want to prove limit is unique. How will you start? Yes, अथर्व यूनिकनेस कैसे प्रूव करते हैं हम लोग? We have done uniqueness for so many things. Payal, perfect, very nice. Correct, good. So you should start with like, hey, it is not working. Just 1 second. So we need to consider if possible there exist two limit, say L1 and L2, correct? Then we'll prove later on that both the limit are same. So we'll start from you can write here. Suppose if possible there exist two limits, say L1 and L2. Hey, no, that is gone. Let f from S which is subset of Rn to R be scalar valued function, that is clear, and let E belongs to S. So you should start with suppose if possible there exist two limits, say L1 and L2 as x tends to E. That means limit x tending to E f of x that is equal to L1 and limit x tending to E f of x is equal to L2. So this is what you should start with. Then what next? What should I do the next thing? Yes, write the definition. What is definition for this? You must consider your x E is in S, that is in Rn, it has n coordinate. So your x is also having n coordinate, correct? So let us write the definition of this first. Maybe I'll write in the next page. Let epsilon positive be given, then there exists delta 1 positive such that norm of x minus e is less than delta 1. Why am I writing norm here? This implies mod of f of x minus L1 that is less than epsilon by 2. Perfect. And for the same epsilon, or for same epsilon positive, there exists delta 2 positive such that norm of x minus e less than delta 2 imply mod of f of x minus L2 that is less than epsilon by 2, correct? Why am I taking norm? Because it is having n coordinate, correct? And here I am taking mod since it is scalar valued function. The image is f of x is in R. So this is what I am having. So what should I do? Next I want a single delta which can work for both the thing. So which delta I should choose? I want a delta which should work for both the thing. Yes. as we are doing everywhere. Delta is equal to minimum of delta 1 and delta 2, correct? Once you take minimum of delta 1 and delta 2, implies norm of x minus e is less than delta, implies mod of f of x minus L1 that is less than epsilon by 2, and this will be the same. And one more thing, f of x minus L2 that is less than epsilon by 2, correct? Okay, what next now? How should you start? You want to prove L1 equal to L2, so what should be your consideration part? Consider mod of L1 minus L2, that is equal to, you should add and subtract fx, no? So it will be L1 minus f of x minus L2 plus f of x, correct? This is correct. So can I use triangle inequality? This is less than equal to mod of f of x minus L1 plus mod of f of x minus L2. What next? This is less than epsilon by 2 plus epsilon by 2, and that is equal to epsilon. So what did you prove? L1 minus L2 is less than epsilon for any epsilon. This is true only. This is possible only when L1 is same as L2, correct? Hence we have proved that limit of a scalar field or scalar valued function, if exist, is unique. Yes, is the proof clear? The same thing whatever you have done for in the case of your R, here you are doing same thing for Rn, and same if you are having Rm here, the proof will be similar. At the place of mod you will be having norm, that's it. So I will be not doing that part. Okay, now shall we go ahead? If you have any doubt in this, then tell me first. Just go back to the proof once again, then we'll go to the next part. Okay, let us go to the next. Recall. Recall. Once you are in real number system, that is in R, correct? If you want to check a limit at this point, then what was the condition there? You used to check from left side and you used to check from right hand side. If both the limit exists, then you say that limit exists. That is, you start with limit extending to e minus f of x, and you start with limit extending to e plus f of x. If both the people are equal, then you say that limit of the function exists. Do you agree? Correct? This was the case in real number because you were going, your x was a real number, a was a real number, correct? But now here the condition is your x is your a is any number in a space, or maybe I will say I'll consider in R2, if I consider, or R3 or Rn, then here is your a anywhere, correct? So now do you see, we have so many ways to come at this point, so many paths. I can come from here also, I can come from here also, I can come from anywhere, correct? Do you see that? In that case you are having only two ways, either you can come from negative side or you can come from positive side. But now to come at this point I have so many ways. You agree? You see that in R, I'll just write in R, for limit to exist, we approach the point, we approach the point from left and right side, correct? But in Rn, how can you approach? You can approach from any direction. You see that from the diagram it is clear. You can approach from any path to this point. Uh, Let me write that also. But in higher dimension, the approach to the point can be along any path through the point. Okay. In a higher dimension, you can come from any path. Your path may be any something ये एक path है, or if I draw it again, then you may consider this is the path which is passing through this point, or this is also a path which is passing through this point. You are having so many paths there, correct? So now the question is that same here, if one of them does not exist or the value is different for them, then what was your conclusion? That limit does not exist. Suppose this is giving me a and this is giving me b, and a and b are not equal, then what was your conclusion? Since the limit is unique, so the limit of the function does not exist, correct? Or one of them is given not defining, or not, one of them is not coming anything value, that is not defined, another exist, then also you say that limit does not exist. Same here also, if the limit exists and the value is different, then what was your conclusion? Or I should ask, if the limit exists, then limit along every path must be same, because limit is unique as I proved earlier. All right. If the limit exists, then the limit along every path must be same, correct? So if you want to write the contrapositive, that means what? If the limit along different path are different, then what can you conclude? Then by uniqueness of limit, we can conclude limit does not exist. Okay, so what do you understand by this? That means to prove the limit does not exist, it is enough to give two paths where the limit is giving me different values. That's it. To prove a limit does not exist. Yeah. So shall we see one example here? Let us see one example. Uh, the question is, check whether limit exists or not. F of xy, that is equal to x square minus y square upon x square plus y square, where x comma y is non-zero and it is 0 otherwise. Okay, so this is your function, and what is your point? If you see, your point is this guy, 0 0. Can you give me at least two paths to come at this point? I want to come at this point. Can you give me at least two paths? Yes? Can you give me at least two paths to come at this point? You can come from any path y equal to x, that is also a path. But the simplest one will be come from x-axis and come from y-axis. Do you see? If I want to approach, like suppose, say, if let us approach, let us approach at 0, 0 from x-axis. From x-axis, that means what? Your coordinate will be x comma 0. That means in your limit you have to put y as 0. So this for limit of the function, limit x comma y tend to 0, 0, f of x, that is x square minus y square upon x square plus y square. This will change to limit x tending to 0. At the place of y you have to put 0 because there is no value of y, only x varies. So this will be x square upon x square, that is 1. So once I'm coming from this path, that is from x-axis, I'm not taking positive or negative x-axis, I'm just taking x-axis. I may come from here also, I don't care, I'm just talking about x-axis. Then or you can say horizontally if I'm coming, then you are having limit as 1. What about the next one? Can I come vertically also? Let us approach at 0, 0 from y-axis. From y-axis, that means what? In y-axis you are having coordinate of x as 0, so it will be 0 comma y. So this limit will be changed to कैसा आएगा वो? This will be limit x comma y tend to 0, 0, x square minus y square upon x square plus y square. This will be changed as limit y tending to 0. Oh, limit, just write it there, and this will be sorry, x will be 0. Sorry. So you'll be having only minus y square upon y square, and that is equal to minus 1. Correct? All right. Y tend to 0, you just consider here. I'm not able to write here. Correct? Correct? So you're having y tend to 0 here. Yeah. So once I'm coming from this path, that is from x-axis, I am getting limit as 1. But once I'm coming from this part, y-axis, I'm getting limit as 1. But since the limit is unique, so it cannot have two different value, correct? So what is your conclusion? What is the conclusion here? What should you write? Since limit of a function, if exist, is unique, implies limit f of xy where x comma y goes to 0, 0 does not exist. Correct? Yeah. Now you may ask, sir, why did you choose only these as a path? The first one is this, and second one, you could have chosen some other path, that is y equal to x also. That is also passing from the endpoint, and you can choose other paths y equal to 2x also. Correct? So you may take any path. Let us see. They are giving me the same thing. Let me show you. Suppose if I am choosing this, what was that? Limit x y tend to 0, 0 and f of xy. Well, I'll not write f of xy, let us directly put the value. That is x square minus y square upon x square plus y square. Now your question would be कि sir, why are taking only this real axis and that is x axis and y axis? You may take any value. So uh, this is y equal to x, this is y equal to 2xy, like that, correct? So this is same as y. So can I take y equal to mx? Let me take taking or approaching the limit along the path y equal to mx. Correct? M is any number, we'll be deciding later on. So if I put y equal to mx, then your limit will be changed into x only. So your this part will be changed to limit x tending to 0, and you will be having here x square minus m square x square upon x square plus m square x square. So can you take x square and get cancelled? It get cancelled. You will be having 1 minus m square upon 1 plus m square. But observe this thing. This guy depends only on m. That means if you put m equal to 1, then your limit you are getting as 0. If you put m equal to 2, then you are getting something else. If you put m equal to 3, you are getting something else. Did you see that? If you are putting m equal to 2, what we will be having? It will be 5, and here it will be 1 minus 4, that is minus 3 by 5. So if you take, so you are getting something in general, that is you are putting some values of m, that is you are moving along that curve. In that first one, that is you are moving along y equal to x, then you are getting limit as 0. But if you are moving from the line y equal to 2x, then you are getting limit as minus 3 by 5. So what should your conclusion be? This implies limit does not exist. Do you agree? Yeah, both the cases here I took from real axis and imaginary axis. So sorry, I go back to the complex. Uh, Here I'm coming from x-axis and y-axis, and in the later case, I'm coming from any curve y equal to mx, because the first condition should be that path y equal to mx should pass through this point 0 0. So is that path is satisfying that? Once it is satisfying, then only you can decide. Otherwise, not. Okay. Let me ask one more question to you. F of xy, that is equal to x square upon x square plus y square minus x for x comma y non-zero, and it is 0 otherwise. Okay, check whether limit of the function exists. Look at the function and try to see which path you should consider. Now in this case, if you go from real axis, that means if you put y as 0, and you will be having x square upon x square minus x, so limit will be same. If you go from y axis, if you put y equal to 0, try to get that, try to get something and tell me. If you go from real axis, that sorry, if you go from x axis, that means you should substitute by, you should change it to x comma 0. That means you need to put y as 0. You will be having x square upon x square minus x. Try to see what are you getting at once you are coming from this way. And same thing if you are coming from 0 comma y, then try to see what you are getting. Or if you don't like this thing, then try to find a path which can make everybody in terms of m. Like in the previous case, I choose y equal to mx, I saw that here it was x square, here it was y square. Degree was same. Here also degree was same. If I put y equal to mx, then x square will get cancelled from both the side. So that's what I should do here. I should think about a path which can make everybody in terms of m. So what path should I choose? Observe that here it is x square. Okay. The problem to me is this guy x. Suppose these two term was again in terms of x, then my life was easier. Everybody will be in x square. Do you agree? Try to see this thing. If this part was in terms of something x square, then it would be easy. So my observation is, let us take limit. We take limit along the path y square equal to, sorry, y square minus x is equal to something m square, mx square, let me put. Can I do that? First condition is whether 0 comma 0 satisfy the equation. Put it in the left hand side, it is 0. Put it in the right hand side, it is again 0. So it satisfies the equation, so I can go from this. Do you see what was my observation? Here I saw this is x square, here I saw this is also x square. The problem was this only two guy, correct? So what I thought, if I put this as in terms of x square, then x square will get cancelled from both the side, and the answer will be in terms of m. So I can conclude for different value of m I am having different limit, so that limit does not exist. Do you agree? How smartly you should think here. So once you go through along this path, uh, pass the which passes through, you should write which passes through 0 0, because you can go from any path. The condition is it should pass through 0 0. Correct? So your limit will change to limit. Yeah, if you put it here, then your function will be in terms of x only. It will be x, it will be x square, and here it will be x square plus mx square minus x, and everybody get cancelled. You'll be having limit extending to 0. Here you'll be having x square, and in the numerator you can take x square common, you'll be having 1 plus m. So what is your answer? You are getting 1 plus m, correct? So if you put m value is 1, you are having 1 by 2. For m equal to 1, you are having 1 by 2. For m equal to 0, you are having 1. See, for the different value of m, you are getting different limit. So what is the conclusion? Limit does not exist. You should write that. For different values of m, we are getting different limit. So what is my conclusion? Limit x comma y tend to 0 0, f of xy does not exist. Do you see? So this is how you should think, correct? Is there any doubt in this question? Tell me first. If limit exists, then along any path it should exist, and the exist value should be same. Here, if I'm going from this path, y square minus x is equal to m square. And how did I observe this? I just try to see that I want to make this guy as in terms of m. So here it was x square, here also I was having x square. So if this term is also in terms of x square, then life will be easy. That is what the thought was. Okay, let me ask you one question and try to do that. F of xy, that is equal to xy square upon 4x square plus y raised to 4, where x comma y is not equal to 0 0, and it is 0 otherwise. Yeah, can somebody tell me, can somebody give me a path where you are having different limit, where you are having different values? Here you cannot take that real part and imaginary part. I hope it is clear to you. Oh, sorry, here you cannot take that x axis and y axis. If you take x axis, that is x and y 0, then you are getting it as 0. And if you put y-axis, that means 0 comma y, then also you are getting 0. So there is no conclusion, limit is same, so there is no conclusion, you can say. Can you give me a path? Think about a path which is passing from this, and this will make in terms of m, everybody will be in terms of m. Try to observe the values. Here it is x y square, this is y raised to 4, and this is x square. So can I make everybody in terms of degree 4? Think about it. Or degree 2, can I make everybody in terms of degree 2? This is 4x square, correct? Can I make this guy as x square? And how can I do that? And can I make this guy as x square? If I want to make this guy as x square, I am having this as x. So I have to put y square equal to x. Let me write y square equal to mx. Try to see the denominator. Is it also in terms of x square? This is already y raised to 4. Y square is mx. So y raised to 4 will be m square x square. That is perfectly alright. Do you see? Just by looking your function, you can decide what do you want to make. Now you may ask, sir, why not can we take x as y square or x as my square? Can I take this? Yes, definitely you can do that. X equal to my square, if I put, then this will be my raised to 4. Everybody will be in terms of degree 4. That is also acceptable. Correct? Whatever you think. So I'll go from this y square equal to mx, taking limit along y square equal to mx. So your function will be in terms of x only, limit extending to 0. It will be y square is m, so it will be mx square upon 4x square plus m square x square, that is equal to m upon 4 plus m square. Correct? And for the what is your conclusion? If you put m equal to 1, your answer is 1 upon 5. If you put m equal to 0, then your answer is 0. So you are having different values for different limit, correct? You should write which is different for different limit of m, different value of m. Hence limit of f of x y, where x comma y tend to 0 0, does not exist. Yes, is that clear? I'll give you some more problem, think about it. Same thing at 0 0. Yeah, I'll put this in Google Classroom also.